Now we're going to dive into the world of aperture and shutter speed and really see how you use these two functions in your day-to-day photography. Let's start with shutter speed. Switch your camera into S or TV mode. Then spin your dial all the way in one direction, then all the way in the other, so you can see the range of your shutter speeds. Feel free to pause the video for a moment if you need more time to do this. Different cameras display shutter speeds in different ways. If your camera's shutter speed is 1/60th of a second, you might see it as either 60 or 1/60. These two mean the same thing. What is your range? You'll most likely have 30 seconds on one end and 1/4000th or 1/8000th of a second on the other end. Let's talk about the extremes first. Think about 1/4000th of a second for a moment. Try to wrap your brain around how fast that is. It's extraordinarily fast. I can't even imagine how they made a mechanism that can operate that quickly. Now, let's talk about the other extreme. Photographically speaking, 30 seconds is a long time. You already know what 2 seconds sounds like. When you take a 30-second picture, you'll hear the sound of the shutter opening, and then you'll hear nothing and nothing. You might go get some coffee. Then 30 seconds later, you'll hear the sound of the shutter closing. When your shutter speed is open for 30 seconds, it means your digital sensor is exposed to light for 30 seconds exactly. Why would you want to use such a long shutter speed? This is an example of a 30-second shot I took in Central Park in New York City. When I took this picture, it was 11 o'clock p.m. When you shoot long exposures, which is anything over 1 second, the camera starts to pick up on light that the human eye can't see. When I took this picture, it was dark, so with my own two eyes, I couldn't see the gray in the stonework. The sky wasn't blue to my own two eyes, and I couldn't see the green in the trees. This is why your camera has longer shutter speed options. During your day-to-day photography, you're not usually using these extremes. You're using shutter speeds in the middle. Shutter speeds like 1/60th of a second, like 1/250th of a second, or maybe even 1/1000th of a second. Now I'm going to show you examples of why you would choose one shutter speed over another. As I show you these examples, I'll tell you what shutter speed was used to take these pictures. This image was shot at 1/100th of a second. This image was shot at 1/10th of a second. This image was shot at 1/1000th of a second. This image was shot at 1 second. What all of these images have in common is that when they were taken, there was something moving in the scene. The difference is that for some of them, the shutter speed was faster, and for some, the shutter speed was slower. This makes a difference in terms of how motion is recorded. This makes sense if you think about it. Whenever you capture an image, you're capturing a slice of time. Your shutter speed determines how long that slice of time is. Is it 1/1000th of a second, 1/60th of a second, 1/2 of a second, 5 seconds? Imagine you're taking 2 images of a speeding train. There's nothing else moving in the scene, and you have your camera set up on a tripod. You're going to take 2 pictures of this high-speed, 160-mile-per-hour train that's about to rip through your scene. The first image is going to be at 1/500th of a second, and the second will be at 1/2 of a second. Imagine what's happening inside your camera for both these images. For the shot at 1/500th of a second, the shutter opens and closes very quickly. Even though the train is moving at a high speed, in the resulting image it looks like it's not moving. Now imagine what happens at 1/2 a second. 1/2 a second sounds something like, how far has the train gone in that time? This is not what's happening, but it's as if the camera is layering image upon image upon image as the train is speeding by. This is why you get the blurring effect, and the result is what we call motion blur. Take a look at each of the images and make sure each one makes sense as far as where it is on the shutter speed spectrum. Now we're going to talk about aperture. This photographer took 2 images at different apertures. We can see the difference clearly. When the aperture number is higher, the background is more in focus. Now let's look at another image. You can see in this image that everything is in focus, from what is close to the camera to what is miles away from the camera. In other words, the foreground and background are in sharp focus. Here's the thing about this image. We cannot tell by looking at it what aperture was used in this shot. Why? Because the subject of this image is bigger than a pineapple. Whenever you take a picture of a subject that is bigger than a pineapple, it doesn't matter what aperture you use. Everything will be in focus. Now let's look at an image that is the exception to what I just said. What we have here is a subject that is clearly bigger than a pineapple, and we have a blurry background. Now I'll tell you why most of you watching this class will never take a picture like this. My guess is that this image was created with a lens that is this big, costs $16,000, and the person who took this picture, I'm guessing, was standing about a half a mile or 800 meters away from the subject. So when I say that you probably won't create images like this, I don't mean to say that it's not possible. What I mean is that for most of you, the equipment you have has limits. If you want to look at creating blurry backgrounds with objects bigger than a pineapple, you'll want to look at getting one of two kinds of lenses. You'll either want a lens called a prime lens, which doesn't zoom but has bigger apertures, or you'll want a telephoto zoom lens. Having access to either bigger apertures, more zoom, or both will allow you to create blurry backgrounds with larger objects. Some of you may already have lenses of this kind, in which case you'll have flexibility with what you shoot. If you have the standard lens that comes with your camera, also called a kit lens, just remember to stick to smaller subjects whenever you want to create the blurry background effect. If you're shooting portraits, do a headshot instead of a full body shot. If you're shooting nature, shoot a leaf instead of a tree. Now let's look at a diagram of just how this works. Just like with shutter speeds, you have choices for apertures. Before I explain how this actually works, I want to remind you not to memorize during this portion of the class. I say that at this moment because you memorizers out there, when you see circles and numbers, your brain starts to go. I'll encourage you to set that aside for a little while longer. Instead of memorizing, just focus on understanding the concepts I'm about to throw at you. I'm going to give you an easy way of remembering aperture, a golden nugget of information you can memorize. The first confusing thing about aperture is that larger numbers mean smaller openings, and smaller numbers mean larger openings. Let's go through a diagram on what apertures give you which results. Let's say you're taking a picture, and in your scene is an object smaller than a pineapple, like a flower. And behind that flower is a background of some kind, like mountains. You take two pictures, and both pictures are focused on the flower. The first image is shot at 5.6, and the result is that the flower is in focus and the background is blurry. You then take the second shot, but now you choose an aperture of 22. Now both the flower and the background are in focus. Before I give you the easy way to remember this, I'm going to explain how this all works, and I'll remind you one more time not to try to memorize this. There's really no need unless you want to be a professional photographer. I'm not sure how many of you do this, but when I'm having a hard time seeing something, I squint. The physics of light that explain squinting also explain how aperture impacts depth of field in your images. The human eye and the camera work in similar ways. If I'm looking at a scene, I'm able to see that scene because there is light bouncing off that scene in all directions. Some of that light travels through the relatively small opening in my eye, which is the pupil. When light travels through that relatively small opening, the scene I'm looking at is projected onto the back of my eyeball, which is my retina, and my brain processes the information. Light works the same way in a camera. If I'm pointing my camera at a scene, the light from that scene travels through a relatively small opening, the aperture, and the scene I'm pointing my camera at is projected onto the back of the camera, which is the digital sensor. From the information the digital sensor captures, the camera creates an image file. Let's go back to the eye for a moment. When you squint, you're actually making your pupil smaller with your eyelids. When you make the opening smaller that light is traveling through, the scene that is being projected onto your retina comes more into focus. It's the same with your camera. When you make the opening smaller, in other words, the aperture smaller, the scene that is being projected onto your digital sensor comes more into focus. This is like having your camera not squint, and this is like having your camera squint. Now that you understand how that works, I'm going to give you the golden nugget of information I promised you, so you'll have an easy way of remembering aperture. This is actually quite simple. A smaller number gives you a smaller depth of field. A bigger number gives you a bigger depth of field. Let's look at the examples again. Now let's do a pop quiz. How did this photographer create this image? The correct answer is a small number. How did the photographer create this image? The correct answer is a large number. Again, just to drive this point home, and remember, this is the golden nugget for you to memorize, small number results in a small depth of field, and a large number results in a large depth of field. The way I used to say it to myself when I was a student back in the day was, smaller number, less in focus, bigger number, more in focus. Now I want to be very thorough in explaining the wording that I've chosen. I want to make sure you're not going out into the world and using incorrect wording if you're talking to other photographers. It is not correct to say that a blurry background is caused by a small aperture, and that an in-focus background is caused by a large aperture. A small number indicates a larger aperture and vice versa, so that is incorrect. It is correct to say that a smaller number results in a blurry background, while a larger number results in an in-focus background.